All right, Algebra 2 friends, we are finishing chapter 2. We're going to talk about graphing linear inequalities. All right, so we're going to start off with a little bit of review. Hopefully you remember we're talking about y equals mx plus b. So you know that this is slope-intercept form. So we're going to start with that y-intercept at 3. Boom, there it is, because it's the y-axis, right? And we're going to work that way. Slope is 2 over 1, so rise 1, 2, and 1. All right, so when we're dealing with it this way, all I got to do is connect these 2 points, because we started off with a nice little equal sign, an equation, so not a big deal. If you can do that, that's primarily everything we need to do. As we change it into an inequality, right, we're going to relate solid and dashed lines to open and closed circles, and then we're going to shade one side or the other. And I'm going to show you 2 different options on how to deal with that. Okay, so we have 3 views of a function. Okay, we have the equation. So what that means is we can deal with it in a couple different ways. So maybe if I have y equals 2x plus 1, right? So we'll just make something super simple here. So we have an equation. What we have to do is be able to manage and work with it. So we know this is a y-intercept. We know this is a slope. So we can work through it the same way we just did the warm-up problem. The next thing we can do is we can have a graph. Right? So those are the things we just talked about. Okay, so I can take this, I can go up 1, I make a point, I go up 2 and over 1, I make another point, and then I connect those. Third one is to make a table. Okay, so if you're not much of a carpenter, we got to pay attention. Hardy har har. Just kidding, right? So this is your table, right? An XY chart. So that means if I plug in 0, what happens in my equation? Well, 2 times 0 plus 1 gives me 1. What about if I plug in 1? 2 times 1 plus 1, that's going to be 3. I could go back to -1 if I wanted. So -1 times 2 plus 1. So we're going to get -1, which makes sense because back here was -1, -1, right? So they all line up. So those are our 3 views as we work with a function. What's going to be different now is this table portion, since it's not just an equal sign, it's going to be a lot bigger, right? We're going to take and we're going to decide what side of this graph. So is it this yellow side that I'm highlighting, or is it this red side or green side that I'm highlighting? That makes up all the answers that I could put into this table to make this equation or inequality true. So that's what we're building on. Instead of just saying, I want the line, I want which half of the coordinate plane works. Okay, so that's a really big concept that we'll continue to talk about. Okay, but first we'll get functional with it so that we know what to do. So this looks familiar, right? We got +3, 1, 2, 3. That's a y-intercept. A slope of 2, so it's going to rise 2, run 1. All right, now we have to start reading. Okay, so this is why this one's used so much in your standardized testing, because there are some little details that we have to recall. And in this one, if this were x is greater than 3 on the number line, right, we would go with here's 0, 1, 2, 3. Would this be open or closed? This would be an open circle because it can't be equal to. For that very same reason, this line is going to be a dashed line. All right. And then the other thing we had to do when y and where an x is greater than 3 is then shade it, right? So then I had to pick what side was greater. Okay, so I can test it out, right? So what's greater than 3? 2 or 4? Well, it's 4, right? But you got so used to that you didn't need anything extra with it. So here's the next thing we're going to do is I'm going to identify 0, 0. So I'm going to first show you about testing it. So this is the point 0, 0, and I'm going to use it for my test. And what that means is this is x and this is y. So is 0 greater than 2 times 0 plus 3? Well, 2 times 0 is 0, plus 3 is 3. So is 0 greater than 3? No, this is false. All right, so what that means is this point right here is false. Now, if you get a true-false question wrong on a test or a quiz, it's simply the other answer, right? So the same idea here. That means when I go to shade this, it's going to be the other side. Now, if that's a difficult concept for you, because I know sometimes kids just don't like that, pick a point on the other side. So I might pick, let's go with this one way up here. It's 1, 2, 3, 4, 5. Okay, so that means this is 0, 5, and it's right here. This I'm going to test it, right? So is 5 greater than 2 times 0 plus 3? Is 5 greater than 0 plus 3? Is 5 greater than 3? That's true. Okay. So in the bare bones of the whole thing, you can pick a point on either side of the dashed line, solid line, whatever it is, test them both. One should be true, one should be false. We are looking to shade the true side. What that means is any ordered pair and all of this green over here will make this inequality true. All right. Normally what we want to do, we really want to test 0, 0 because it's so easy to plug in and we don't have to worry about changing signs or even writing an ordered pair backwards or anything like that. Okay, so let's try it again. Let's throw this one here on our coordinate plane. I'm going to start off at -1 because that's my y-intercept. So a good review of graphing lines. I'm going to go up 1 over 2, up 1 over 2. So I went from the y-intercept to the x-intercept. Stop for just a second, double check the inequality. Okay, so it's another dashed line because it would be an open circle on the number line, right? We're making that connection the whole time. And now I'm going to test 0, 0. So is 0 greater than 1/2 of 0 minus 1? Is 0 greater than, all right, so I'm getting tired of this part, right? 0 times 1/2 is 0. 0 minus 1 is -1. Is 0 greater than -1? Yeah, true story. Okay, so this is true, which means everything on this side is true. Right, if you don't believe me, you're going to take another point somewhere out here. So maybe 1, -3. Plug it in here. Okay, so is -3 greater than 1/2 times 1 minus 1? Is -3 greater than 1/2? Is -3 greater than -1/2? No, that's false. Right, so that's kind of the proof in the pudding there and what's happening. Again, if you understand what I'm saying about being on the true side and shading that side, then go with it, right? So if it was false, we went to the other side. If it's true, we're going to stay on that side. All right, next one we have, oh, look, this one's in standard form. Hello, standard form. How I have missed you, my friend. So the x value, right, 2x equals 6. So x must be 3. 1, 2, 3. 3y equals 6. So y is 2. All right, now you're saying, Mr. Tola, you put equal signs in. You told us not to do that because it's inequality. All right, so here I'm just trying to find an intercept. Right, so nothing matters until right now. Should it be solid or dashed? And here's what I tell my students. You ready? If it has a solid line, it is a solid line. Okay. I mean, you also know from inequalities that we would fill in that circle, which means it counts. So filling in that line, making it a solid line, that's the connection we're trying to make. All right, other thing I like about standard form, because you guys know I'm a big fan of standard form. I work with the equation, whatever way it gives, that's what I'm going to do. So I'm going to test 0, 0. All right, test 0, 0. Look at this. 2 times 0 plus 3 times 0 is less than or equal to 6. 0 plus 0. Is 0 less than or equal to 6? Yeah, that's true. What's that mean? We're going to shade this side because all the answers to this inequality that we started with are on this side of that line. Okay, if you don't believe me, you can check the other side. All right, but I'm hoping you get the idea now. Yeah, like, okay, I got the idea. Why do we have more examples? Well, because what happens with this one? I keep saying test 0, 0 because it's super easy. What happened here? We started on 0, 0. It's on the line. Now what do? I don't know what I'm going to do. 1, 2, 3. Well, I know what I'm going to do. I'm going to put the line on here. Okay. It has a solid line, so it is a solid line. Okay. Remember, it can be equal to, so that line counts. Like, great. Do you have a tip for this one? All your tips have been fantastic, right? That's what I think that you're thinking about my tips about graphing this. But maybe it's not true. Hopefully it is. So here's your next tip. You're allowed to pick any point you want anywhere on this entire graph. My suggestion is take an ordered pair that repeats. This is the point 1, 1. Why do we do that? Because if I put it in backwards, it really doesn't matter. right? Because if y is 1, I want to know if 1 is greater than or equal to 3 times. Is 1 greater than or equal to 3? No, that's false. This point is no good. So what side of the line is good? Well, the other one, right? We don't go over the answers to true, false. It's the other one. Okay, so if it's false on the right-hand side, on the left-hand side, it is true. All right, got another one in standard just because I'm going to review that because I like it, but I know I haven't sold everybody just yet. So here we go, negative 2x equals 6. So x must be negative 3. X, 1, 2, 3, boom. As we said when I was in junior high, whoop, there it is. All right, negative 3y equals 6. So y must be, that's part of my equal sign, negative 2. All right, I got my 2 points. I'm going to double check the inequality itself. It does not have a solid line, so I'm not going to make it into a solid line. It's going to be another dashed line. I want to test 0, 0 because it's available. All right, so negative 2 times 0 minus 3 times 0 is less than 6. 0, 0 is 0 less than 6. True story. Tell it again. So this is true. So I'm just going to keep shading here. I didn't even change out to a highlighter. That's it. That's the answer. All right, what if it's not in standard form? It's not in slope-intercept form, right? This is kind of the way life is. Sometimes things just don't work out perfectly the way they are. So we're going to adapt and we're going to make it look like things that we're used to. So you have an option here. Do you want to make it into standard form or do you want to turn it into slope-intercept form? And I would venture to say we want to turn this into standard form, right? Because that's a lot easier. All let's do is add 2y. Okay, so I got 5x plus 2y, unlike terms, is greater than negative 1. If I go through all the work to make this y equals or y is greater than, eventually I'm going to have to divide out this negative, or I'm going to move a bunch of stuff around and then divide. And if I divide by a negative, I got to change the inequality. There's so many places I can make a mistake. This is definitely the easiest way to do it. All right, so now you're saying, yeah, but look at this. I got to do 5x equals negative 1. Okay. X is negative 1/5. Here's 1. Here's 1/5, or close to it. Okay, and look at this one. 2y equals negative 1, so y equals negative 1/2. About halfway. That's not too bad. All right, now, the thing I want to do is check the inequality. So this is a dashed line. All right, 0, 0 is available. It is available. So right here. So it's on the top side of this line. And I want to try and use the original. I know it sounds a little bit silly, but if I made a mistake somewhere in here, I don't want that to cause another mistake. So I'm going to go back to the original. I get 5 times 0 is greater than negative 2 times 0 minus 1. So is 0 greater than, right? All this stuff goes away. Is 0 greater than negative 1? Yeah. Yes, it is. Okay, so this is true. That means this point on the top or the right of this line is true. So that's where I'm going to put my shading. All right, looks like we got just 1 or 2 more of these, and then we're going to jump into the absolute value. So I'm just going to kind of sketch some things through it. It's kind of flipped it around the way that you want to see it. And the reason I did that is sometimes kids really want the equation to be set a certain way. But remember, we're just going to work with it the way it is. So I just want to find intercepts. Okay, so 5 equals 10x, divide by 10. So x, remember, is 1/2. So if that's 1, 1/2. And then we'll work this way as well. 5 equals negative 3y. So y is negative 5/3. Well, that one I'm going to have to change, right? That's going to be negative 1 2/3 on the y-axis. 1, 2, 2/3. Now I'm going to double check my inequality. I'm only looking for solid or dashed here. That's a dashed line, my friends. We're going to check out this 0, 0. Okay, and it's in standard form, but it's kind of written in reverse, but that makes it super easy to check. Okay, so hopefully we realize it's going to be 5 less than 10 times 0 minus 3 times 0. If you get this part that these all turn into 0 is 5 less than 0? No, no. Okay, so this is no good. We're going to the other side and we're shaded. All right, we got number 8. I'll just jot this one in real quick. X, 2x equals 15. So that means x has to be 7.5. 2, 3, 4, 5, 6, 7, 8. So 7.5. All right, other half of it, negative 5y equals 15. So y must be negative 3. Solid or dashed. Dash line. Test out 0, 0. There it is. So 0, 0 is 0 greater than 15. No, that's crazy talk. I like to cross it out. We shade the other side, and then we're all set. All right, so the next thing we're going to do is work in reverse. So this, my friend, is the graph. What inequality made it? All right, so I got y. I'm going to start backwards, right? So I have a y-intercept of 2, so plus 2. What's the slope? I'm looking for a nice point. So here's a nice point. How do we get there? I rise 1, 2. I run 1, 2, 3. That's the whole thing, right? Now, the next thing I have to notice is 0, 0 needs to give me a true statement because this is shaded. So when I do this and I say 0, right, this whole thing here turns into 0. So 0 compared to 2 has to be true. So we know 0 is greater than 2. Last thing I do is I double check the line. The line itself is dashed. So I'm going to leave it as y is less than 2/3 x plus 2, right? If this were a solid line that I put in yellow, we just put that equals 2 part on it. But otherwise, that is our final answer. All right, let's try it again. Remember, we're going to start in reverse. So I'm going to start with my y-intercept, negative 2. Then I'm going to find my slope. So I'm tracing it back. Okay, here's my other nice point. So I'm going to go down 1, 2 over 1, 2, 3. So negative 2/3 this time. And I want 0, 0 to be false. So that means when I compare 0, right, this term goes to 0. So I'm going to compare 0 and negative 2. Well, 0 is actually greater than negative 2, but I need to make a false statement. So I'm going to say that 0 is less than negative 2 to finish out my inequality. Okay, so we have to understand if it's shaded or not, that we're trying to make a false statement. It's kind of like lying. It feels so bad teaching to lie. Okay, but that's what the what inequality is required for this problem. Okay, so other than that, don't lie. Okay, that's a bad thing. All right, let's take a look at absolute value graphs. So we know that these are those V-shaped graphs, but look what I did. I threw an inequality in it. Okay, so we know this one has not been translated. It has the equals to, so we're going to use a regular shape with a V, up 1 over 1. All right, now, when you started doing number lines, it all kind of made sense, right? Greater than was to the right, less than was to the left. Same thing here. Since our absolute value kind of is always shaped this way, we're going to work with it the same idea. So the y values have to be greater than our absolute value. So that means it's all the ones above. Right? When the lines start to turn sideways, then it's a little bit hairy. That's why we deal with it the way we do. All right, so I know this one is eventually going to be below, but I have to figure out what's going on with it first. We got a lot of stuff going on here. Okay, so first thing is outside is down 2. So I know it's down 2. All right, so we talked about this a little bit. I know it should be right because it's minus, but it's not going to be 6. So remember what we have to do is we have to take this out. We have to solve it. And it turns out x is 2. So that means I'm only going to go to the right 2. So it's right 2 and down 2. And that goes along with this. Right? This was minus, so I know it should be to the right. But since this multiplier was inside, it's not going to go 6. It's only going to go 2. All right, so that's our V shape. Next thing, all right, that's our vertex. Next thing we're going to look at is the absolute value. So solid or dashed. Hey, solid or dashed? Are you paying attention or not? I'm just kidding. It's a video. I can't tell what you said. All right, so dashed it is. It is upside down as well. Right. So now I have a choice. Since its y is less than, these are all the numbers below. Okay. Right, so we're picking the numbers below. All right, so that's the introduction into our absolute value graphs. We're going to throw those in front of you because my hope is that everything with these inequalities for linear graphs was a review. So we're going to just build on absolute values while we're here. All right, see you in class.